Hey guys, welcome to my research. I discovered that a lot of students take this topic as a hard one, a challenging one. So I added some animations into this one and colors to ease up all the stress and to increase assimilation from the student. This is Introduction to Electrolysis, the preliminary course to electrolysis. I'll go straight to the point. Now, electrolysis is the decomposition or breakdown of an ionic compound, molten or in solution, by the passage of electricity through it. Excuse me. I will expatiate on this statement. Now, this is the decomposition or breakdown of an ionic compound. Decomposition. Please mind the pen. Or breakdown. I'd love to do that again. Decomposition or breakdown. Excuse me. I tag this prerequisite number 1. According to the Merriam-Webster's dictionary, composition is to cause something, such as a chemical, to be separated into smaller or simpler parts. At the end of electrolysis, the original substance is decomposed, is broken down, is changed into simpler substances than the original substance. So the end products are always simpler than the original substances. For example, electrolysis of water, the end products are hydrogen and oxygen. These are simpler products than water itself, that is the original substance. If you look at this example, we had lead bromide as the original substance, right? And now at the end, we have molten lead and bromine gas. Let's move to the next one. Of an ionic compound. Prerequisite number 2. Why? Now, why are only ionic compounds used for electrolysis? Let me explain. Ionic compounds have ions contained in them, the concept of ions. If you haven't watched ionic bonding from my research, right now you see the link, please click it and watch it before I continue the video. Now, ionic compounds consist of ions, and these ions are the energy carriers in the electrolyte, are able to move the energy from the cell to the other part. I'll explain this further in the next prerequisite, that's in molten or in solution. This is in diagram form here. Let me erase this. Let me erase this. Okay. Let me become blue now. Okay, now let's go. Molten or in solution. If you look at this diagram, this bulb does not light. Why does it not light? Okay, let's assume that we don't know why it does not light. Now we'll go back to the prerequisite. Ionic compound, check. Electrolyte is an ionic compound, yes. So why is it not lighting? It's because if you look at passage of electricity, yes, there's a cell there. But why does it not light? It's because it is not in molten or in solution form. Why? Molten or in solution form enables the ions to be able to move, and because if they cannot move, the bulb will not light. For example, if you want to do an electrolytic cell with sodium chloride, table salt, if you put the cell and the wires when dry, nothing happens. But if you add some water, the water frees the cells, fills the ions in the sodium chloride, and enables it to conduct electricity. And this is what happens in this diagram. Because the lead bromide is solid, it cannot conduct electricity and the bulb doesn't light. But when we hit strongly, this fire, yeah, when we hit strongly, it becomes molten. Then, as you can see, the lead ions and the bromine ions are free. Now, the electrolytic reaction occurs. Let's quickly come back to terms. Electrolyte. This is the substance that conducts electricity when in molten state or in solution. As I've explained you earlier, the electricity is carried through the electrolyte by the movement of ions. For example, hydrochloric acid sodium chloride, sulfuric acid, etc. In other videos, I will explain weak electrolytes and strong electrolytes. But for now, let's understand that electrolytes are substances that conduct electricity when in a molten state or in solution. These substances are ionic compounds that contain ions. They consist of ions. That is basically what electrolytes are. I'll advise you to pause the video and screenshot it so that you'll always have all this handy. The electrode, a conductor in form of wires, plates, or rods through which current enters and leaves the cell. The name given to the two species of electrodes are cathode and anode. This is a very funny and intriguing part. Let me go to what color shall I use? Green. Make it a little lighter. Yeah. Now, very intriguing part because the cathode is negative, right? But positive ions come to it. Positive ions are the cations, but it's negative. Because it's negative, there's the force of attraction between positive ions and the negatively charged cathode, right? And then negative ions are attracted, the positive ions are attracted to it. That is why it's called the cathode. While the anode is positively charged and attracts anions, and anions are negatively charged ions. And let's come back to this. Right. I call this dim. Why? Now the three prerequisites when defining electrolysis, it usually comes out in most exams, especially WAEC. Use the keyword dim. What does dim mean? It means decomposition, ionic compound, molten, or in solution. Now what does this mean? It means that when you want to define electrolysis, these three keywords must be there, because electrolysis cannot occur without these three things. So if you want to just remember the three things, just use them. The composition or breakdown of an ionic compound in molten or in solution. You can track me later. Okay, thank you. Let me wipe all this off. Okay, now the uses of electrolysis. A lot of uses, but I'll highlight a few of them. Extraction of elements like aluminium, purification of metals, and electroplating of metals. Electroplating of metals is the most widely used of electrolysis. Very common: silver-plated saxophones, chromium-plated plates, spoons, etc. Very common nowadays. It is one major use of electrolysis. I will explain it further in other videos. Thank you for watching. Please comment and give me more examples of electrolysis, and you can leave a suggestion for me in any part of the video you'd like me to work on. Thank you for watching. See you next time. Bye.